Today we're taking a look at angles and their measurements. Now an angle is simply a shape that's formed by two intersecting lines, rays, or segments. And they intersect at a common point. That common point is called the vertex of the angle. Now an angle is also a measurement, and it's measured in degrees, usually ranging between 0 and 180 degrees. We'll take a look at that here in just a second. But when we name an angle, there's always a particular naming convention that we use. So let's take a look at our example over here on the right hand side. We have a ray RS and a ray RT. They form this angle SRT, which the common point from which these two rays diverge is R. Therefore R is known as the vertex of this angle. When we name it, we're always going to use this little angle symbol. So here's one way to name this angle. I'm going to name it using 3 points, SRT. Now I can go in the opposite direction and I can name this angle TRS. You'll notice that R always comes in the middle, and therefore, because it's the vertex of my angle. I cannot name this angle RST. That does not follow the naming convention needed to name the angle appropriately. Now I can also name the angle just using the vertex point. So this is angle R. And I can also use it by numbering the angle on the interior of that angle. Therefore, this could also be known as angle 1. Now, you guys have learned the many types of angles and how to classify those angles. An acute angle, you'll remember, is any angle that measures greater than 0 degrees but less than 90. As soon as I get to 90, I see that I have a right angle. An angle to 90 is known as obtuse until you get to 180 degrees. As soon as we're at 180, you now have a straight angle. Those are the 4 classifications of the angles that we're going to be looking at this year. All right, now you also may have learned how to measure an angle using a protractor. Here we have examples of a few angles, and you'll notice that the angle's vertex are always at the origin of the protractor. So the origin is the center of that base line, and you'll see that one ray of our angle always passes through the 0 or 180 degree mark. So let's take a look here. We want to find the measure of angle SRC. So starting at S, passing to the vertex R, and then up to C, I'm looking for the measurement of this angle right here. So I'm going to start on the inside numbers and count up 0, 10, 20, 30, 35 degrees. So the measure of this angle is 35 degrees, and I know that this is an acute angle. The next is CRT. C starts here, down to R, my vertex again, and then back up through T. Well, I can see that there's this little box right here. That box indicates that this is a right angle. So its measurement must be equal to 90, and I'm classifying this as a right angle. The next one is DRS. So D starts here to R, my vertex, and then back out to S. You'll see that this forms a straight line, and this is 180 degrees. So this is 180, and this is known as a straight angle. Finally, I'm looking at angle DRC. So D to R, and then out to C. Now, let's change colors here, and we'll grab red. That's this angle right here. I can see that that's greater than 90. That's an obtuse angle. So I'm going to be counting on the outside part of my protractor, 10, 20, 30, 40, all the way to 90. 1, 110, 120, 130, 140, 145. So the measure of DRC is 145 degrees, and this is an obtuse angle. All right, moving right along, we come to a new term called the angle bisector, and this is just like our midpoint, but it's for an angle. So an angle bisector is simply a line or a ray or a segment that divides another angle into two smaller congruent angles. For example, number 2 says JK bisects angle LJM. So here's JK, my ray, passing right through the center of LJM, and that means it's going to cut through and create two smaller angles that are congruent. Now these are called arc marks. These arc marks, again, because they're identical, indicate that these two angles are congruent to each other. So I'm going to indicate that angle LJK is congruent to angle JK. All right, now the angle addition postulate is very similar to the segment addition postulate, which remember just means simple fact or truth. that whenever we have two smaller angles, those will add up to equal the whole angle. So in this example here, we see that we have these two smaller angles, angle 1 and angle 2. I can say that angle 1 plus angle 2 must equal angle B in this case, or angle ABC. The two smaller angles add up to equal the larger angle. All right, in example 3, we're simply asked to write the names of this angle as many ways as we can. We have our 3 points on this angle, H, D, and R. The vertex of this angle is D, so therefore it needs to be listed as my middle number, or my middle letter. So I'll call HDR one angle. And then the other way to name this same angle is RDH. Another way I can name that is angle D, and then a fourth way here is angle 1. Now, what is not a proper way to name this angle? I cannot name this angle DHR. And the reason why is that our vertex always needs to be listed in the middle. All right, for our next example, we see that we're going to use the angle addition postulate to solve this. We're going to make our drawing. Actually, we already have our drawing, and we're going to list what we have. So we know that the measure of angle ABC, that's our larger angle ABC, is equal to 84 degrees. So the way I denote that is to put a big arc mark through that and 84 on the outside. Now I also know that ABD is 62, so A to B to D is my smaller angle, and that's 62 degrees. And I'm going to put that measurement inside the angle. Now I want to find the measure of CBD. So here's my missing amount, this angle here. I'm just going to let it be known as X. Now according to my angle addition postulate, it says the two smaller angles must add up to equal the larger, or the whole thing. So X plus 62 must add up to equal 84. Here's simple algebra from here. We're going to subtract 62 over to the other side of the equal sign, and I'm going to be left with 22 degrees. So the measurement of CBD must be 22 degrees. All right, for our final example for today, we see that JK bisects LJM. Now, I'm going to underline bisect because, again, that word is very important. It tells me that the two smaller angles must be equal. And anytime we know that two measurements are equal, we can set their expressions equal to each other. So I see that I have LJK. This guy must be congruent to MJK. And I also see that I have expressions for those two smaller angles. LJK is 4x plus 11, while KJM is equal to 6x minus 11. Now again, because it's bisecting, I know that these two smaller angles are congruent to each other. Whenever I have congruent angles, I can set their expressions equal and solve for x. Now from here I'm going to combine like terms. I'm going to move my 4x over here. It goes away on this side. I'm left with 11 is equal to 2x minus 11. Now I'm adding 11 over to the other side of the equal sign, so I end up with 2x is equal to 22. When I divide off that 2, I'm left with x is equal to 11. Now, that doesn't answer my question fully. I needed to find x in order to find the measure of LJK. So LJK is right here. Its expression is 4x plus 11. So that means I need to take 4, multiply it by 11, and then add another 11. That's 44 plus 11, which is 55 degrees. Next, I want to find the measure of LJM. That's the entire angle. Now, because JK is the bisector, I know if this guy's 55, then the next one must be 55 as well. And therefore, together, they must add up to equal 110 degrees.